Yeah, thank you, Willem, for the invitation. Um, Today I'm going to talk a bit about DHL and how we use BAZEL and DHL. Um, Maybe first of all, a little bit of context about our situation at the company. Uh, we started with a front-end monorepo about 2 years ago, a bit longer. It's one Git repo with an increasing number of applications. We started with 2 applications in January 2020, and we have been adding more applications over time. The last update on the slide is on January this year, and back then we were at 21 applications. Currently, I think if we count again, it's maybe 24, 25. So it keeps increasing. We keep adding more applications. It's new applications, but also existing applications that we migrate to the monorepo. So what does that give us? It simplifies the code reuse. You can easily create shared libraries and share them between applications. When we make an update, this update is immediately available to all the other applications. So that's useful because if you change something, you also run all the tests that are needed. There's no updating something and then figuring out 2 weeks later that it doesn't work in one of your applications. You know straight away that it works or not. It's also great for knowledge sharing. We all work in the same repo, so we see each other's pull requests. Even if you're from another team working in another application, you still see the work of your colleagues. It's really useful because, we have like maybe 25 applications right now, but we only have maybe 10, 12 front-end developers working full-time on these applications. So there are more applications than there are developers. That helps if you share the knowledge and you can help each other to still get time to work on your features. It's also helping us to make consistent technology choices. All the applications are built with the same stack. So we use React, but all the applications use React. They all use the same version. If we add something, we discuss it among all the front-end developers, and we can keep a consistent technology view. It's not without pain. The build performance became a problem as we grew. We started out with a Jenkins build, and we used Lerna. That helped us great for the first 1.5 years. Performance was okay, but when the number of applications grew and we got more people working inside the front-end repo, we noticed that the build became slower and it became a bit of a struggle to work with. To give you an idea, back then, before we switched to BAZEL, 20 minutes was really lucky. It was a good number.
Yeah, was good, but it was too slow, so we moved to BAZEL. Somewhere in the autumn of 2021, with the aim to reduce the time.
BAZEL is the build tool. It's the open source version of Blaze, and Blaze is the build tool built by Google. Google has been using this tool internally for over almost 2 decades now. So it's well tested, it's well used. And 7 years ago, they released an open source version of it. In the beginning, the API was not really stable yet, but the last maybe 2 years, the API became stable. It's So it became a lot easier to use BAZEL. The documentation has improved over time dramatically. It became easier to use. There are more examples available. So, well, when we had the option to choose something to improve our build system, we started to look into BAZEL. So today I'm going to talk to you a bit what's needed to convert your build to BAZEL. What do you gain by it? How does it work? Give you some high-level overview of how our CI system works now. So let's start with what you need to do as an application programmer to use BAZEL. First of all, and that's the most important task that you have to do as a programmer, is you have to describe your build graph. You can group your source files into targets, and targets are things like building a TypeScript library or bundling some JavaScript files into a bundle using Webpack or ESBuild, or it can be something like building a Docker image if you have some files and build a Docker image out of it. All these targets are related to each other. So one target might depend on the output of another target. And it's your task as an application developer to describe this build graph. The build graph can be quite simple, as you see here, but in our case, it's quite a big graph with hundreds of nodes with all small parts, and they all are connected together as needed. So when you do that, you have to keep your build hermetic. Hermetic is something that you see if you read about BAZEL. TypeScript library. But if you forget to specify this dependency, your build is not hermetic. You might over-specify the build graph, so you might specify that something depends on something else in your BAZEL build file. Well, it actually doesn't, but you can't go the other way around. You can't forget something. If you do that, your build is not hermetic. It might be some source file, it might be the result of another target, but your build is also not hermetic if you depend on some globally installed tool, or if you depend on some system environment variable. You can still depend on external tools, of course, but you have to specify them inside BAZEL. You have to tell BAZEL that your build can only run if you provide this environment variable or if you provide this external tool. And this way, your build becomes hermetic. The second thing you need to do as an application programmer, of course, go back to this slide. You might think, well, this sounds brittle. I might forget something. Might be a mistake. I thought it was. I thought the Webpack build didn't depend on the library, but it does. How do you prevent such mistakes? Well, BAZEL has the concept of a sandbox. So every target that gets executed in a sandbox. And the best way to think about a sandbox is to think about it as a random new directory. And what BAZEL does is it copies all the dependencies, so everything that you specified as an input dependency gets copied to this sandbox directory. And in this sandbox directory, BAZEL will execute the command. So for the Webpack build, of course, it will copy the library it depends upon. It will copy the source code itself. It will copy Webpack itself. But it will also copy Node, because we had to specify Node as an external tool to BAZEL. So BAZEL knows we are using Node. And you also copy the Webpack configuration. And when all the input files are in the sandbox, then we execute the command itself inside the sandbox. Now your build will fail if you forget to specify one of the dependencies. And that way you see immediately, I forgot to specify this package as a dependency, or I forgot to specify this file as an input dependency to this target. The second thing you need to do is make sure that your build is deterministic. So what do we mean with deterministic? It's that your output of target should only depend on its input and nothing else. That sounds like a reasonable assumption for a compiler. I assume that the output of my compiler only depends on the input files that I provide. So that makes sense, but sometimes there are cases where it's not obvious, but it can go wrong. For example, if my build depends on a Docker image and I specify the tag of the Docker image. So I depend on the Docker image, but then the owner of the Docker image pushes a new version, but it overrides, it uses the same tag. That's possible with Docker on Docker Hub. You can just push another image using the same tag. So that would mean that if I run my build today, I can get a different result than if I run the build tomorrow, because something might change in between on Docker Hub. Something else that might change is, for example, if I have a build step that takes a file and generates an archive of it, just a zip archive or something like that. Then the current date of the file will get encoded into the resulting zip document. But that would mean that it's not exactly the same file that gets generated today that will get generated tomorrow. BAZEL will generally solve these issues by asking you to not only supply a tag of a Docker image, but also to supply the hash. And for the file dates, you will see that Docker will always use the 1st of January 1970 around midnight. So it's always the same date that you see, and you have to specify the hash. So that's what you need to do. What do you get in return? First of all, you can easily get parallel builds. As you can see, we have multiple targets in the build graph, and you can already see that you can bundle the two Webpack builds and the ES build in parallel with each other, just by looking at the build graph. So BAZEL will look at the build graph and see which targets are independent of each other, and if they're independent of each other, we can run them in parallel. Second thing is we can cache results of a target. Because we have been so strict in specifying all the inputs, we can now use the content hash of the input files as a cache key. If we have the same input files, we can go to the cache, use the input files as a cache key, and look in the cache and see if there has already been a set of output files that has been generated with these specific input files. If we find a result, we don't have to perform a Webpack build, we don't have to perform a TypeScript build, we don't have to invoke Docker or something. We can just go to the cache and get the resulting files straight away. This will make sure that we never compile the same code twice. We never test the same code twice on CI. That really speeds up the CI environment. For example, if I make a pull request, I change something. I change one of the 25 applications that we have today. Docker, BAZEL will still build all these 25 applications, but 24 of them are in the cache, so we get a complete cache hit, and only the last one will actually be built. Then I merge the pull request, and another master build will run. And the master build will see the same code as we have already seen in the pull request build, and it will get all the 25 applications from the cache. So that also gives us a tremendous speed up in our build times. The third thing that it gives us is that we can run targets across multiple build machines. Sometimes you have a pull request that still needs to build all the 25 applications that we have. For example, if we update React and all our applications use React, we have to rebuild all of our 25 applications. But that would mean that we have to run quite a number of Webpack builds. We still use Webpack for most of our applications, and only some of them are using ES build right now. So we have to build something like 20 Webpack builds in parallel. And on a single machine, that's a bit too much. So what you would like is to distribute these 20 builds across maybe 4 build machines. So we can all take 5 builds and take those 5 builds, build them. You can do 5 Webpack builds in parallel on a single machine. That still works. And then at the end, we can combine it together. Since we have been so strict in specifying all the input files, we can say, well, we have this sandbox that we talked about earlier, where we copy all the input files to. You can also say, well, this sandbox doesn't have to be on the same machine as when we started. No, it doesn't. We can also create a sandbox on a different machine, copy over all the input files, and execute the command that we need to execute, and then transfer the output files back when we get the result. So that's the third thing that we get, and it also gives us a good speed up, especially if we have to build more than one application in a single build. So how does that work if we start looking at our CI system? We talked a bit about how BAZEL works from a programmer's point of view, but how does our CI system work today? We switched to GitHub runners. So whenever we push a commit to GitHub, one of our GitHub runners will start, and it will basically do 2 things. It will check out the repository, nothing strange, and it will execute the BAZEL build //... command. The //... basically means just build everything. It's the wild card. Build everything. Build the whole repo. Build all targets. This also means that we have a nice separation between what's our CI system and what's our build system. We can easily run everything that the CI system does locally. We can check out the repository, and we can also run BAZEL locally. So that's a nice way to separate those things. It makes it easy to test parts of our CI system locally. So what's the first thing that BAZEL does? It will first construct the build graph. So it will read all the configuration files that we have written as application programmers, and it will start to construct the build graph and keep a representation of it in memory. Then it will look at the first target that it has to execute, and it will look up all the input files, and then it will calculate the cache key, and then it will look up the local cache to see if there's already a copy of the output files available for this specific set of input files. We will keep track of a cache on the GitHub runner itself. That's the first layer of cache that we use. So BAZEL will first try to fetch the output files from there. Every GitHub runner has its own local cache. That might fill. Then we have a second cache, a remote cache. And BAZEL will try to download the output files from a remote cache if it can't find the output files in your local cache. So that's the second step. The remote cache is shared by all the GitHub action runners. If also the remote cache doesn't result in a cache hit, then we have some new code that we haven't seen before, that we have never compiled, that we have never tested. So we take that code and we start to execute that. It doesn't get executed on the GitHub runner itself, but instead BAZEL will transfer the work to the scheduler. And the scheduler will just keep track of the build queue. The queue, it's just the queue, and it's shared among all the GitHub action runners. So my build might run on the first GitHub action runner. It will put a little bit of work in the queue of the scheduler, but the build of my colleague will be executed by another GitHub runner, and this GitHub runner will also put some work in the same queue. Then the work in the queue will get distributed among a set of workers. Currently we have about 18 workers, so we can execute 18 different targets at the same time. When the worker executes the command, of course, at the end we have a result, and we write the result back in the remote cache, and we also transfer the result back to the GitHub action runner. This is a signal for the GitHub action runner that runs BAZEL, and BAZEL determines, okay, we have done this step now, what's the next step? And the process will repeat until the whole build graph that BAZEL knows has been executed. You see on the left part BAZEL that runs on the GitHub action runner. You see on the right part the remote cache, the scheduler, and the worker. They communicate with an API. The left part is strictly BAZEL. The right part is our remote cache and remote build execution environment. Because it's an open API, it's defined. There are a couple of implementations. To name two open source implementations, there's build barn, there's build farm. But you can also use software as a service solutions like Build Buddy or Ankflow. Currently at DHL, we are using build barn on a Kubernetes cluster. So we deploy the scheduler, we deploy the remote cache, and we deploy 18 different runners inside our own infrastructure. So that's the part that builds our Docker images. The end of this part is just a set of Docker images. For the applications itself, it's an Nginx container with our JavaScript, our CSS, and our HTML inside. And for the end-to-end test, it's a Cypress image with additional layers with our testing code. What we do next is we execute the end-to-end tests. And for an end-to-end test, we create a temporary Kubernetes namespace. And in this Kubernetes namespace, we deploy the application itself. We deploy the APIs that it needs. We deploy the database if it needs a database. We deploy Kafka if the API needs Kafka. We deploy additional services like keycloak or whatever it is. It can be anything. As long as it's a Docker image, we can run it. And on top of that, we deploy the Cypress image. It's the Cypress image that was built by BAZEL, so it's Cypress with an additional layer with our tests inside. We still use the BAZEL cache for this. So if we see that we are testing the same Nginx container and the same set of Cypress tests and the same API and the same database and whatever it needs, if we have already executed those tests, we take the results from the cache and we never deploy anything inside this temporary namespace. Only if there are changes to the API or changes to the resulting Nginx or changes in the test itself, then we will execute the tests inside the Kubernetes namespace. That's nice because we can scale up Cypress simply by running more Cypress instances in the namespace. It depends a bit. Some applications have a lot of tests, so we might deploy 4, 5, or 6 instances of Cypress in parallel. Other applications are a lot smaller, and we just run one instance of Cypress. Then the next thing that we can do is helpful for debugging. It's preview environments. So sometimes when you make a pull request, especially if you work on the front end, you want to show your work, maybe to your product owner or to a colleague, before you actually hit the merge button. So what we do is we have the ability to specify a label on a pull request in GitHub. And when you do that, the only thing that will happen is that we won't clean up this temporary Kubernetes namespace. Normally, at the end of the build, we all clean them up, they are gone. But if you add a label, we keep the namespace, we keep your application running there. Of course, Cypress is finished, so it's gone, but all the other containers are still there. And because we place them behind an ingress, you can access them directly from your web browser. They get a unique URL based on the pull request number. You can share that with colleagues. And only if everyone is happy, you can merge the pull request. So that's a bit about our setup at DHL, about how it works. If there are any questions.
Are there any questions here?